All right, this is the review for test number 1, page 2, first sheet with questions on it in the review packet. Again, the way you should be using this review packet is you should be, trying the problems on your own and then watching the video to go through the solutions. I'll try to remember to pause as I read these to sort of encourage you to remember to try them on your own. So the first one is kind of just a memorization problem, but list the 4 steps of the scientific method as was presented in class. So go ahead and take a minute, pause the video, and write out the steps. All right, so let's start here. I'll write out step 1. The first step, hopefully you wrote down to make an observation. All right, scientists make an observation. And they might say, well, that's interesting. I'm observing this happening. That's really interesting. And then they think about, all right, well, why is that happening? Let's formulate a hypothesis or an educated guess, hypothesis, as to why that particular thing that we observed might be happening. And then the third step is they're going to make a prediction. I observed XYZ happening. I think it's happening because of this, whatever physical property, right? So my prediction is going to be, well, if I take something else and do the same thing to it, or I run some test, I'm going to get certain results based on what I understand. Right? So in class, we talked about, for example, air pressure in tires, right? So you might observe that your mileage varies, right? So you might hypothesize, well, I think tire pressure might have something to do with gas mileage, right? I think gas mileage is affected by tire pressure. So then you predict, well, if I make the tires based on what I know about the way cars work, if I put more air in the tires will be firmer. They should roll a little better. I should get better gas mileage. And if I drain some of the air, I have softer tires, I'll get worse gas mileage. And then you go ahead and run an experiment, right? And this experiment either supports your hypothesis or doesn't support your hypothesis. Then you have to go back and think about, okay, maybe I made a wrong assumption, or maybe I misunderstood something, and reformulate your hypothesis, make new predictions, and run new experiments. All right, number 2, the only way a hypothesis can become a law or accepted at all is through what? So again, think about it. All right, so the answer here is experimentation. This is what we use to validate hypotheses, right? Make a hypothesis, make a prediction, and then run an experiment. All right, so this one here, number 3, the amount of gas in a cylinder is fixed. If the volume of the gas expands to twice its original volume, the pressure on the gas is cut in half. Based on the statement, which of the following correctly represents the relationship between the pressure and volume of a gas? So we've got 2 proportionality statements. Pressure is directly proportional to volume, and pressure is inversely proportional to volume. And then we've got options A, or neither one, and then both. Right? So we can see by reading this as if the amount of gas in the cylinder is fixed, if the volume expands, right, the volume increases, the pressure is cut in half. Right? So if one variable increases, the other one decreases, which relationship is it? And in the first relationship, we've got pressure is directly proportional to volume in a directly proportional relationship. As one increases, the other one increases. As one decreases, the other one decreases. Over here, we've got an inverse relationship. As one variable increases, the other one decreases. As one variable decreases, the other one increases. So this is This is the correct choice. Right? P pressure is inversely proportional to volume. Right? As V increases, pressure decreases. All right, number 4. What are the units for density and what physical quantities do they stand for? The units stand for. You can actually look this up. You can just look at the table and find, oh, density, grams per cubic centimeter, right? So let's write that out. The units are grams per cubic centimeter. And they stand for mass, that would be G, and volume. That's centimeters cubed. All right, number 5. Go ahead and look up in your tables from the formula sheet that will be given to you on the test. Again, this formula sheet is going to be given to you on the test, so you'll have all this information. Go ahead and find replace the power of 10 in the following measurement with the prefix. So go ahead and do that. All right, so the power of 10 is this times 10 to the negative 2. Right? We're going to go to our metric prefix table and look up, oh, times 10 to the negative 2. That's over here. That's 1/100th. That's a C, which is centi. So we're going to replace that with a C. And we can write this as 38 centimeters. Right? So we're replacing the power of 10 with a prefix and making sure we also bring the actual unit of measurement along, meter, right? 38 centimeters. All right, number 6, again, more of a memorization question, which is broader in scope and covers a larger framework of knowledge, scientific principle or scientific theory? Pause the video, think about it. And the answer here is scientific theory. Scientific theory is larger framework, broader in scope, and typically it consists of a lot of scientific laws and principles. All right, number 7, what's the mass in grams of 1 cubic centimeter of lead? So we know the material lead, and we can look up the density of lead in our table here, 1.3. We see the density of lead is 11.4 grams per cubic centimeter. Let me write this down. Table 1.3. Density of lead is 11.4 grams per cubic centimeter. Right? So for every cubic centimeter, there's 11.4 grams. Now you can plug it into the formula if you wanted. Right? The density is mass over volume. You can write that down on a separate sheet of paper. Right? We want to know the mass. To find the mass, come over here. Mass is density times volume. We can plug in those values, right? We can plug in the 11.4 grams per cubic centimeter. And we can plug in the volume, which was 1 cubic centimeter. Okay? So in this case, because we're given 1 cubic centimeter, we're multiplying this density by 1. So really, the only thing that's changing are the units on this. The centimeters cubed is going to cancel out, and we're left with a mass of 11.4 grams. So that's how you would do this problem if you needed to calculate it, if you were given some other amount of volume. Alternatively, you can see that for every cubic centimeter, there's 11.4 grams, and you can just answer it like that. Finally, the last one, what two environmental factors affect the density of a material? So think about that. All right, so the two factors are temperature and pressure. And density is mass over volume. Typically, temperature and pressure don't affect the mass, but temperature and pressure affect the volume of a material, right? So increase the temperature, a lot of materials expand, volume gets bigger. Decrease the temperature, a lot of materials shrink, volume gets smaller. If you increase the pressure on something, the volume gets smaller, right? You're squeezing it together. And then if you decrease the pressure on something, the volume gets bigger. So these two environmental factors affect density because they affect the volume. All right, that's page 2.